Hello, everyone. Welcome back to my podcast. I'm David Pompiani, and I have an interesting show today. We're going to talk about the famous footprints at White Sands, New Mexico, the 20 to 23,000 year old footprints everyone's been hearing about. And today I brought on the show some guests who have looked at the dating of these footprints a little bit closer and has brought to light some information that might, let's say, undermine or prove that these footprints may not be as old as we think. And so I want to introduce the guests we have today on the show. I have Dave Rachal. He is a independent geoarchaeologist from New Mexico who's worked extensively at White Sands, and he has done a lot of groundwork actually examining footprints from humans and other creatures at the site. And he has also been featured on Desert Drifter YouTube channel, where he did an awesome job showing the site to the host of that channel. And then we have Loren Davis. He's an Oregon State anthropologist, and he has co-authored a paper along with David Rhode here from the Desert Research Institute, a research professor, examining the dating at White Sands. So guys, thank you for joining me on the show. I'm really excited to talk to you all. The first thing I want to get into today is the actual site, White Sands, where these footprints are found. And Dave Rachal, can you tell me a little bit about the site where these so-called these supposed 20 to 23,000 year old footprints are found?
Well, they're located on the eastern margin of Paleo Lake Otero, and Paleo Lake Otero is this lake that was there around 25,000 years ago during the last glacial maximum. And the prints are in this kind of mud flat depositional environment. And those mud flats just have a lot of megafauna tracks and human trackways. It's quite the environment where you have really great preservation. Just because the lake would drop and expose expanse of the mud flats, people would walk across it, and the lake would rebound and bury the tracks. And that's essentially rinse and repeat for thousands of years. Above the trackways, you have the White Sands dune field, and that formed around 5,000 years ago during a big mega drought during the Middle Holocene, called the Holocene Altithermal.
Okay. This mud flat, so you're calling it a mud flat. Would you say that's like a littoral zone in the lake when it was at its like maximum stand? So it's like an area that is shallow even when Lake Otero was at its maximum volume, right?
Right. The lake is pretty persistent on the western side of the basin, and that's just because there's a lot of faults. But you have this really broad plain toward the east. So the lake would be persistent on the west side, but then we have these periods of rainfall and hydrological inputs into the basin, and the lake would rise up and spill out over that plain. Just like a tidal flat in Rocky Point, if you've been to Mexico, Puerto Penasco, it'd be similar to that.
Okay, so this is the outlet of the lake. You're essentially this.
Yes. Now, keep in mind that there are different interpretations of the depositional environment of locality too. I think it's a mud flat, but a lot of the track folks are really pushing this idea that Lost River flowed through there and it created this deltaic type of environment. And that's really important to their story because they argue that you had these freshwater inputs pulsing fresh aerated water into the site that minimize the hard water effect. I personally think that it's more of a mud flat depositional environment and there wasn't a delta going through that area.
Okay, because I just had Vance Holliday on here, and he's a co-author in the original Bennett article in 2021. And he mentioned this freshwater pulse, this reduction in the hard water effect from this, you're saying deltaic fresh water coming into the lake during the LGM that might have reduced that hard water effect. And so I was not familiar with that, but you're in the camp that you think it's more of like a mud flat and and that this hard water effect persisted in the past.
Right. The issue with the whole Lost River hypothesis is, it's really hard to determine if it's connected or not because you have all these yelling sand sheets obscuring the drainage. The other issue is that the pupfish, the New Mexico Tularosa Basin has this endemic pupfish, and the fisheries biologists always saw the spring-fed drainages that pour into the lake as evidence of at the pupfish in these ranges is evidence that they were connected to Lake Otero. So the Salt Creek to the north, which contains Ruppia, has the pupfish, so that's thought being connected. The Lost River never had pupfish. They were introduced in the 70s, I think. So there's a really good chance it's not connected. One thing about the connection, it's really hard to substantiate,
Okay. Interesting. All right. And so we have this lake. We know it's at least a shallow environment that creatures are able to walk on because we see footprints clearly. So let's just, leave that issue aside. You mentioned that we're in White Sands. It's a national park, right? Or state park? Or
the national park now.
National park now.
It's about 2019, something like that, or 2018. It was a national monument before that.
So this is recent.
Dating to the 1930s.
So these White Sands are contained in this basin that once held Otero Lake, which would have been a large lake that existed during the last glacial maximum. Last glacial maximum globally is around 18 to 22,000 years ago, roughly speaking. So Lake Otero existed around that time. It was a big freshwater lake. And then it's slowly evaporated away since the last glacial maximum. And then around, Dave, you said the mid-Holocene, there's a mega drought that dries out the lake bed and causes it to produce dunes, these that are made of white sand. So can you explain, what is this mid-Holocene drought and what are these white sands? What are they made out of?
The sands themselves are composed of gypsum, and the gypsum is sourced to geologic formations that surround the basin and the mountain uplands. So during pluvial periods, the gypsum's dissolved, it gets flushed down into the basin. That sulfate basically loads in the Paleo Lake, and if the Paleo Lake dries out, you have a lot of precipitation of evaporite beds, gypsum beds, and then the wind scours it out, creates these gypsum dune fields, the largest gypsum dune field in the world.
And this happens around 5,000 years ago?
That's correct. Yes, give or take a little bit. And that was just a time where we just regionally in the Southwest and locally too, we had a lot of just mega drought. It didn't matter where you were at. If you were in a mountain lake in the Colorado Rockies, they were at a low stand. Here in southern New Mexico, we lost all of our grasses and the shrubs marched in, so we had a lot of bare ground. You have a lot of bare ground, you have a tremendous amount of erosion. You had stand replacing fires in the Sacramento Mountains. It was just a really hot, arid time, and that's when the dune fields formed. Now, why is that significant? Is that scouring out of the lake bed exhumed thousands, if not millions, of megafauna tracks and trackways and purported human tracks and trackways along the margins of Lake Otero and within the interior of the Lake Otero. That's called the alkali flat.
Okay. So we can definitely all agree that those footprints and tracks in the mud have to at least be 5,000 years old. That's our minimum consensus age for those tracks, at least. We're starting at 5. We're moving up. The lake dries out around then. And speaking, like you said, I know like Lake Bonneville, all these big salt lakes that are, the Salt Lake, and across Arizona during the LGM, there was lots of big freshwater lakes that are now pretty much salt flats, right? And they dried out. I thought they dried out earlier in like the late Pleistocene, but you're at least at Otero, it had water in it in the early Holocene, but by about 5,000 years, you're saying it's dry.
Yeah, the lake, it's the watershed. You have all these big mountains surrounding it. So, it would dry out, but then, the lake would rebound during wetter times. It held water off and on until about 7,000 years ago. And then it got scoured out. Water table dropped, and then wind scoured out that lake basin, creating little divots, and then it started to hold water off and on again during the late Holocene.
So what kind of vegetation is around the lake today, and what kind of vegetation would have been around the lake 20,000 years ago?
Good question.
Whoever wants to answer that, if someone wants to jump in.
So for during the last ice age, the vegetation would have been dominated around the lake by shrublands and pinyon juniper woodlands of the Colorado pine, Pinus edulis. In the mountains, you would have a mixture of pine forests, southwestern white pine, a limber pine, ponderosa pine, and at the very tops, you'd get a little bit of spruce. So what you see on some of the very higher mountains in northern New Mexico now, you would have seen that lower down in altitude in southern New Mexico, surrounding Lake Otero. Vegetation right around the lake would have been shrubland, but probably not quite so dominated by the creosote bush and stuff that you see today. Would be more kind of high desert shrubs. Sagebrush was dominant, and we know that from the pollen that was taken from the White Sands footprint site. So that's what was growing at the time, the footprints, well, at the time, coeval with the footprint.
Mm-hmm.
Yeah, coeval with the footprint, whatever time that was.
Because they analyzed pollen grains, which I'll get into for radiocarbon. They looked at the composition of those grains. So back then we have more of what you would consider like a forested environment, let's say, in the LGM.
Yeah, more of a montane.
Yeah,
montane to upper Sonoran open pine woodland, as opposed to Chihuahuan Desert, which grows around
today.
There right now.
So Chihuahuan Desert today is what dominated by cactus species, shrubs, herbs, things like that.
A lot of agave.
Agave. Okay, interesting. And
Dave Rachal would know more about the local veg.
And there's a specific species that grows in and around the lake that was particularly used in the study that produced seeds. What is the name of the plant that they dated again, Dave?
It's
Ruppia.
Yeah, Ruppia cirrhosa, the spiral ditchweed.
Spiral ditchweed. So
also
describe
called widgeon grass.
What is that? How does it grow? What environment?
Well, first thing to know is it's an aquatic plant. It doesn't grow on land, terrestrial. It lives in an aquatic environment. It's generally about 0.5 meter to several meters worth of water. I think maybe the limit of depth, maybe 2 to 3 meters, depending on the clarity of the water. It is an aquatic plant that loves hard water environments. It does better in those than any other aquatic plant. It's one of the best. Certain species of ditchweed grow in brackish, basically seawater around the world. And then there's this species which grows in continental environments, also around the world. So it's an common aquatic weedy plant. It's got fine filamentous stems and leaves and little flowers that are underwater, but they kind of produce pollen that comes up on gas bubbles and floats around on the surface and allows pollination to happen, which produces these fruits, the fruits of which can be radiocarbon dated. They're very sturdy fruits. They can last in sediments for a long time. They're very, very tough. And so they preserve very well in aquatic sediments. And for that reason, and because they're tough, paleoecologists have used them for radiocarbon dating throughout the world for aquatic environments. The problem, though, is that, and we'll be getting into this in more detail, is because the plant loves these hard water environments. It loves saline. That's where it gets its carbon, is from the water column. It doesn't get any from the atmosphere. And so whatever carbon is in the water that it grows in, that's what it's subsisting on. It photosynthesizes it. It collects that stuff and produces its structures from that carbon. And that carbon may not be, often is not, in equilibrium with the atmospheric carbon. And so as a result, you get a distorted impression of what the age of the plant is. It's using carbon that may be quite a bit older than the carbon that is in equilibrium circulating around in the atmosphere.
That basically makes the date too old. If you radiocarbon dated the Ruppia seed, it would just essentially be too old if it's getting a lot of old carbon.
Yeah, it's a plant that is notorious about lying about its age, basically.
So the Ruppia doesn't live there today because it's too dry and it's no water, correct?
There are some very small populations found. Well, some of them are pretty good stands, actually, but there are populations of Ruppia in some of the springs and ponds in the basin nearby in a number of different pond settings. Some of these ponds may be fairly large, but they're spring fed. There are some very small populations that have been collected from places like the Lost River, which is this ephemeral drainage that comes out of, the Sacramento Mountains to the east, that has been collected there. But overall, it's not found in Lake Lucero, which is the modern lake that is ephemeral kind of a lake that currently occupies the Otero Lake Basin. As far as I know, it's not found there. And so it's pretty much restricted to some of these spring wetlands and in the area.
Okay. Now, the site that the dates, the Bennett and the Pagodi paper, at that site proper, it's totally dry with no living Ruppia nearby, correct?
That's correct.
Like within a kilometer or two, Okay, so it's dry there. And then so the Ruppia is found at the footprints there, isolated from the sediment, the seeds. So it shows that when it was wet, there was living Ruppia, at least there, or being transported there by water to the site where the footprints are found or preserved in these dry lake sediment bed layers in the former Otero Lake. Okay, so go ahead.
To back up a little bit, you mentioned that it may be transported by water. A great way to transport Ruppia fruits and vegetation is by wind. The ditchweed, it can get kicked up by wave action and uprooted, and it forms these strand lines along the shorelines of lakes, creating these kind of masses of drying out Ruppia, vegetation and seeds, and they often, by the action of wind, turn into these balls that Rachal has been calling Ruppia balls. I mean, they're very common in the area. We know that they were being formed there. They're being formed perhaps, for a very long time. And that may be a real important indicator of what's going on with this site.
Dave, Rachal?
That's what makes Ruppia trippy. First of all, it's extremely unreliable, as Dave Rhode said, and that's a scientific fact. Second of all, when you hear Ruppia, just think tumbleweed of the lake. And that plant will get around. It has a very, very fast, rapid colonization rate because the seeds can float, and it can stay afloat for days, weeks to months. It can easily go from one side of the lake to another and get deposited on shore as shoreline wrack, as Dave Rhode was explaining. So Ruppia, the tumbleweed of the lake, highly mobile, and I don't think that the trackway folks really paid attention to that detail, and that's important. One thing about the stems and the seeds, it's the reproductive, buoyant part of the plant. I provided graphics for you to look at when you do the video and you do your editing. The tip top, that's the flowering part of the plant. And that thing breaks apart and it floats, and the stem stays attached to the seed. It's like a rudder for it, and it helps get pushed around on the current. But it can seriously mobile.
Okay, that's a good thing to know. Let's hold off on the Ruppia. So we established, this is what they're going to eventually use to radiocarbon date these footprints, this seed. And so let's just step back. Let's build up to this Bennett paper, which is the original Bennett et al. Science paper in 2021, which originally, put forth the radiocarbon dates of these Ruppia seeds. But as I am interested in just the history of the finding footprints at the site, period, the type of creature tracks we find there. So Dave, Rachal, you've worked there quite a bit. What kind of footprints are found there? When were they first recognized to be footprints? And can you fill us in just a little bit of the history of that site up to the Bennett 2021 paper?
Well, they were first documented in the 1940s or 50s, but they were sloth tracks, and some trapper thought it was like Bigfoot footprints. After that, I mean, the New Mexico Geological Survey was out there in 2007. They started doing a lot of work with megafauna tracks and trackways, and it was probably around that time when they started identifying the human footprints. And then a lot of work has been done on them since 2018. But there are quite a few of them out there as far as megafauna tracks go. I mean, you could find proboscidean tracks or mammoth tracks, sloth tracks, camelid tracks, direwolf tracks. There's felid tracks. The preservation is really, really excellent, but they're all over the place. And then you have these human tracks, and some of them, some of them definitely look human, but some of them are just little blobs, and it's real easy to confuse a sloth track from a human track if there's a lot of deflation, because a lot of them don't have digits. They're just little blobs.
So what do you mean by deflation? Just that the digits are worn away?
Right. Erosion, wind erosion.
Erosion. Okay.
One thing Ruppia's tricky because it's mobile. Gypsum's tricky because it's soluble. Right? It's a very ductile mineral. It'll wet and dry, and it'll dissolve and reprecipitate out. It's very friable. It's easily deflated. And all those taphonomic processes can alter the footprints, mar the shapes. It's really, really complicated, and it's not that straightforward, in my opinion. But yeah, I mean, you could have a sloth track that gets eroded over time, and it'll change the shape, and it can become more humanoid. So on and so forth,
Mm-hmm. And in the sediments themselves, I have a little bit of a background in lake sediments. To find lake sediments that are totally gypsum is very weird. So I'm assuming when the lake is wet, it's not, evaporatively enhanced, and the ions are concentrated to the point where gypsum can precipitate. What is the normal sediment? Probably clays, silicate clays, carbonates. And then interbedded with gypsum. I know the top is clearly gypsum because of the processes and the wind that you mentioned with water. But when the lake was there, those sediments are probably gypsum, maybe halite, some kind of clays from the parent material in the watershed, silicate-based clays, and then probably carbonates, calcite, aragonite, or some polymorph, maybe a magnesium-rich or strontium-rich carbonate, because it's a very hard water lake. So maybe are the footprints perhaps not in gypsum? Maybe. I mean,
well, no, some of them are gypcrete. We call it gypcrete locally. I mean, it's like hardened gypsite. Some of them are dolomitic.
Okay.
And we don't really understand that. Some people say that's just flowing water flowing into the prints and it precipitates, but it could be something diagenetic too. We don't really
there's a
know.
lot of things. Mm-hmm. Mm-hmm.
The issue, though, is that once they become lithified, they become resistant to erosion, and the surrounding soft sediment gets blown away, and the megafauna tracks become pedestal.
Whoa! So they almost compact the sediment and almost pre-lithify it, like push the pores together.
Yeah.
Whoa!
That's the phenomenon. Are lithified pedestal megafauna tracks. But there are lots of mechanisms that we need to figure out. And
because finish. But I was going to say 20,000 years old is not very old even if it is 20,000 for a truly lithified anything.
Get this, oryx tracks will go through the same process. So whatever's happening is happening relatively quickly. So oryx tracks will become lithified, pedestal. If it's on the right type of gyp mud, they'll actually expand and contract and actually grow in size. It's a taphonomic nightmare out there. It really is. It's very complicated just because gypsum is tricky.
And that's, I think, why it's lithifying so fast, is because it's made of the cementing process at this site is probably very quick with the gypsum and carbonates and halite. Probably salt is in there, and that, once it dries out, will fill up pores and lithify. Anyway, okay, so we have sites. We have tons of footprints there. It's clearly a real lake before 5,000 years ago, so the footprints had to have been put in before 5,000 years ago. And sometime when did the lake form? Let's just be extreme as we can. What's the oldest limit for the Lake Otero, the basin? 1 million years old? Or is there like a rift basin that's been forming or something? Extension? Not sure. Okay. I would imagine it's 500,000 years old or more, but I'm not. That was just like a thought experiment. So we have 5,000 years as when the lake is dried out, and it formed sometime, let's say during the Pleistocene, mid-Pleistocene or something.
What we do know is the lake did expand and contract. It was low between 25 to 35,000, and then it rebounded around 25 to 20 or so. But the chronology is not that great because it's based on organic matter, But that's what we think we know.
So we need someone to drill that site and get a long core and do some proper dating. I mean, that's like there's those big rift basins they core like in Africa and South America. Lake Junin is this super old basin in the mountains of the Andes. It's been accumulating sediment for like 500,000 years. So this Otero sounds like one of those kind of lakes, but the problem is the dating. So hard to date sites like those. So you can get a long core, but if you can't get any dates, it's not worth anything, or you can't use it for much geologically. Anyway, we have those footprints in there. They were originally recognized by some trappers. They thought it was Bigfoot, it was sloth, but long story short, they were recognized professionally in 2000s as being real footprints. Then Bennett, in 2021, produces a paper, Bennett et al., and I'll have that in the description for this video so you can click and look at it. They excavated a trench in a dry part of this mudflat, exposing the layering, and anyone correct me if I'm wrong, and they looked at the layering in the lake, and they were able to find layers with footprints and then human footprints, and they're preserved. They provide pictures for these footprints and a schematic of where the footprints are found in the layering, and they then took Ruppia seeds from those layers at first. This is the Bennett article, and they dated them. And these dates on these seeds from the layers these footprints are found in are scattered. So they used 11 seed dates, eventually produced 11 seed dates. And these grouped around 20 to 23,000 years ago. Am I right? And that was published. Am I right, guys? Is that what the story for Bennett 2021 is? Bennett et al. Now, in that paper, they didn't fully account for the fact that Ruppia has this hard water effect, and it grows in the water. It obtains its carbon from the water. It's highly mobile. And so in 2021, your friend and colleague, David Matson, he commented, published a proper comment on the article. For those that aren't scientists, you actually send in a comment. And he makes this point. He raises the issues with this paper published by Bennett saying these Ruppia seeds are too old, and for the reasons we've already stated, and a bunch of other reasons that they might be wrong. For example, there's no artifacts that are 20,000 years old found in the Otero Basin, as far as I know, at least published. There's none. There's no physical artifacts, so they raise that issue. And the age model, the chronostratigraphic sequence of the dates is very strange. It's over 30 centimeters they obtain these dates from, so a 30 centimeter thick sediment deposit roughly. And they grab a bunch of 11 dates from those 30 centimeters of sediment. And the dates actually are not as linear as you would expect. So Dave, do you have a comment on that? Dave, Rachal?
Yeah, one thing that they did is they date, you're right, those sea layers are really in just centimeters apart from one another. But one thing that they did is they used uneven sampling and large seed dates to create their chronology, right? So one seed layer, they would date 40 seeds. The seed layer above that, they would date 130. And the seed layer above that, they would date 80. So on and so forth, right? What they're doing is smoothing out the hard water effect, right? If you went through and date the individual seeds and use the smallest sample possible with even seed dates, you'll find age reversals. And so that's a little bit of a magic trick. So you'll see flip-flops.
So we're averaging. It's almost, smoothing.
Right. And there's no logic of like, why did you use 40 from one seed layer, and then the one above it 130. And 130 seeds for AMS dating is like 7 dump truck loads, right? I mean, it's a lot of material to date. You can get away with a couple of seeds. So they smooth the chronology out, and that's what makes it look like it's in correct stratigraphic order. Now, if you were to go back and date them all in small seed samples, like I said, it'll be flip-flop. There'll be age reversals. And that smoothing it out doesn't get rid of the hard water effect. It just hides it.
They did also provide one charcoal date. Is that, I forgot to write that down, but does that charcoal date consistent with the Ruppia dates? Even though
that
it's just
charcoal
one?
date is from a different site. It's from what was it, a backhoe trench or something like that, some distance away, that they were using to try and provide some correlation to the dates that they got. But it's one piece of charcoal in an alluvial setting, and you don't know where that thing came from. So it could be any age, it could be redeposited, could very well be redeposited older charcoal. And so the use of that date, as far as we can tell, really doesn't provide a whole lot of clarification about the ages of the Ruppia dates. One other thing I should mention about those is the 10 or 11 Ruppia dates. 4 of those are replicates. So they took a bunch of the Ruppia fruits and took them to split them into 2 piles and then dated those. So what looks like 10 dates, wow, that's a lot, or 11 dates, it really boils down to about 6 that aren't replicated.
Okay. Well, that's good to know. Dave Rachal?
One other thing, too, is that if you start looking at the seeds, the linear seed dates for some of the trackway horizons, like trackway horizon 6, there's 1,000 years just in that seed layer of variation. I mean, and that was consisted of like 50 seeds, 60 seeds, 80 seeds, and they still couldn't smooth out that 1,000 years. And I think that's a pretty interesting point.
Okay. Strange. And so Bennett, 2021, puts out the paper. Your colleague Matson, 2022, raises these issues. Bennett comes back with a response to the official comment and attempts to address this by saying that long story short, that there's minimal groundwater contamination because of maybe this deltaic freshwater environment that they claim is coming in. And they argue that the charcoal, which should be terrestrial based, which is my experiences lake sediment dating and hard water, have actually been a little bit more reliable than definitely aquatic material. I didn't realize it was from a different place and not from the site itself. But anyway, Bennett raises they had the charcoal date and that should be not affected by the hard water. And you guys just said why that might be an issue. And they address kind of indirectly the fact that there's no artifact evidence dated around the lake, a hearth, a piece of even a cultural, pre-Clovis style projectile points. Nothing physical around in the Otero Basin has been dated to 20,000 years old. That is definitely a human artifact. They say that we shouldn't judge their dates based on the lack of information. And I guess that's a decent point. And, this might prompt re-examination of the archaeological record around Otero. So fair enough on that point there. Anyway, this then, I guess, maybe controversy with the dating spawns a little bit more investigation, rightly so. And eventually the group that Bennett was a part of, a lot of the same co-authors, produce another paper following other, missing some other papers by like Jack Oviatt. I was at Kansas State, by the way. He was there, but he was retired by the time I was there. Jack did some papers. He did a paper in Q quaternary research that I don't have right here. But there were some other papers coming out after Bennett, raising issues with the dating, a little bit more detail. But then Pagadi, I think that's how you say their name, in 2023, Pagadi et al., 2023, provided new forms of dating at the site. and this is outside of radiocarbon dating, called optically stimulated luminescence. So that's OSL dating. And this has to do with the exposure of quartz sand grains to light. And that's why it's called optically stimulated luminescence. And then that produces a luminescence in the grain that could tell you the last time the grain was exposed to sunlight. They found quartz grains in a stratigraphic layer where these footprints are found. And this date from OSL dating comes to greater than 21.5 plus or minus 1.9 thousand years ago. So 21.5 thousand years ago. This is consistent with their radiocarbon dating. Now, why do you guys have an issue with these OSL dates as well? Loren?
So before we jump into the OSL thing, let me just say as a bridge between the 2021 and then the later papers is that essentially our response, so Dave Rhode and myself were on the paper with Dave Mattson. Our response was essentially you can't date these footprints at Ruppia because of the reasons we've been talking about. Ruppia is not a very honest quarter of its own age. Even more importantly, the footprint itself has to be dated some other way because you can always get organics, even like we mentioned, charcoal or some other plant could have died sometime in the past and then get reworked and redeposited. So there's always a question about what is it that we're dating? Because when you get a radiocarbon date on an organic thing, you're not dating the moment of it coming to rest. You're dating when that plant died, when that animal died. So if we want to date a moment, like a sedimentary moment, creation of a footprint, we have to have some other technique. So in this paper, we said, we need to use the other methods. And so we recommended using optically stimulated luminescence. But we also were saying, need to sort out this issue of whether there's a hard water effect. And Bennett and others, they essentially just responded with rhetorical arguments. They just simply said, don't worry about it. We don't think hard water effect is a thing. And so we were kind of frustrated about this. And so we put our heads together and thought, how could we actually address this in scientific, rather than having it be a yes, it is, no, it isn't kind of argument back and forth. And the OVI et al. Paper that you mentioned was really key because, and I want to hand the mic to Dave Rhode because he came up with a really good idea on how to address this. And also Dave Rachal did some of this work too.
Okay, what was that good idea, Rhode?
Well, that idea was if there is a hard water effect in the Tularosa Basin of Ruppia, we might actually see that in modern Ruppia samples from the various places that it grows. And so we found a modern sample that was collected in 1947 by a botanist from the University of New Mexico and stored there at the University of New Mexico Herbarium and dated that modern plant. And the date came back about 7,400 years old. So it's a pretty good indication of the magnitude of the effect, the hard water effect that Ruppia will display modern samples. And it could well be the same case. Now, it may not be exactly 7,400 years old, but it's a real good indication that in that basin, Ruppia really does show significant hard water effects. If you were to, say, subtract 7,400 years from the dates that Bennett et al. Reported, you get dates in the neighborhood of 14 to 16,000 years old, which is not out of line with what we already know from pre-Paleo-Indian or pre-Clovis sites in North America. So
okay,
that was my idea.
Yeah, now I'm going to just throw something crazy out here. Why'd you date plants in 1947, not a plant today?
Well, we didn't have access to plants immediately today. I didn't know Dave Rachal at the time, but we also knew that wanted to find where there might be some plants, and we happened to find one there. There was another little tricky thing in that after 1947, there was a lot of atmospheric nuclear tests that went on that really changed the amount of carbon-14 in the atmosphere. So if you were to get more modern plants, then they would be affected by what is called the so-called bomb effect. So that is something that we wanted to try to avoid. Now, Trinity, the atomic test out there, happened in, 43 or 44? But that was a one-shot thing, and it didn't really have any effect on global atmospheric carbon-14. So it is, I wanted to try and avoid that problematic situation. So I went to the herbarium sheets.
That's amazing that you actually had something from 47, because I saw that bit and I was like, they even got like pre-bomb carbon something to date to choose that hard water effect. Because if you did a modern plant today, I bet you it would date into the future because it's be so radioactive. I think that's that's what we've found is, modern things in the West are radioactively dated to the future, or radiocarbon dated to the future.
So but that would be true for the plants that are getting their carbon from the atmosphere. Not from Ruppia, which gets its carbon from the water in which it lives.
So in parallel with this great idea that David Rhode was having, Dave Rachal, great minds think alike, I guess you could say,
had the same great idea.
Was doing the same thing. We didn't realize it. He was doing the same thing, but he was doing it in other ways. So I'll let him tell the story.
Yeah, you tell us about that.
Well, while they were doing their QR paper, I was running around the eastern shoreline, and I found the Ruppia seed balls or lake balls, right? And I picked one up, and I thought, oh, man, this is so great. And I thought it was a coprolite at first. It looks like fossilized feces. And then everybody told me that's what it was. But then I brought it back home and looked at it under a microscope, and I realized there was no mastication or anything like that, no digestive fabric to it. And that's how I came up with the idea of lake balls, which I thought was really great because that was really, they established that the hard water effect is there in the basin, it can happen, and lake balls connects it to those wetlands because the plant can move from one side of the lake to the other. After that, I read their paper, and they were talking about carbon isotopic values and how you can use that to get an idea if the plant's pulling in bicarbonate or not. They had a date of 7,500 years, calibrated years BP, and that had an isotopic value, I think, of a negative 13.7. So, I thought, well, okay, let's go out to the Salt Creek, which the plant still grows in. It's about 45 kilometers to the northwest of locality 2. And I thought, okay, one of the complaints, everybody says, well, Ruppia is really unreliable because, it's unreliable because you date it comes back thousands of years, but there's also a lot of spatial variation in it, right? So I thought, okay, well, maybe this weakness is a strength. So I went around and picked up these different plants from all these different settings and radiocarbon dated it. And I got a range of Ruppia dates from around 2000 all the way up to 8,800 years. And there's a relationship between those age offsets and the carbon isotopic values. And then I created a curve. And then I was able to get the isotopic values from seeds from seed balls. And then with what we did with Dave Rhode and Loren Davis, we're able to get some of the isotopic values from seed dates from Vance Holiday. And we were able to come up with a correction which fell somewhere around 11,200 to 15,800. It's a wide range, but you have to realize like what we're doing is, we're just trying to get it in the ballpark here. And it was a very cowboy way of going about it. But it worked out very nicely.
Now, if you add that correction, then what would the ages be? If you account for that, like you said,
it'd be 15,800 anywhere to 11,200, I think. If it Dave.
Oh, okay, that's the age. Okay, I thought that was a correction you're adding. Okay, so then if you add the correction, it would be those dates would move from 20 to 23 to 15, or sorry, would you say 15 to 11?
Yeah.
Okay. Yeah, give or take. And I'll put up, when I edit this, we'll have graphs up as we talk it, because I'll be able to pull things up and the viewer should be able to see a little bit more detail too. Now, let's get back to the OSL dating, though. The radiocarbon dating of Ruppia seeds, I think we've established there's issues here. The OSL dating tries to get around that. So OSL dating requires quartz grains to be exposed to sunlight and then be sequestered from the sunlight in sediment. You then isolate these quartz grains under red light, and you analyze the amount of luminescence they have, and it tells you when they were buried. Pagadi in 2023 as kind of the response, but with a separate article say that the OSL dates are 21.5 thousand years old. Why do you have an issue with that date as well?
Well, the big issue, as we said in our first response to the Bennett paper in 2021, was that OSL should be used for the things that you mentioned. It should be used to get an idea for the timing of when the footprints were buried. Because if you get an OSL sample right above a footprint trackway, it'll tell you the timing of when those footprints became put into the dark, so to speak. When were they buried? How long have they been in the dark? So we specifically said, get OSL ages that are right on top of each of the different trackways. So they're kind of linear. You can measure them out. Just sample the sediment that's burying the track. What they did later on was not that. They went and took some OSL samples from a stratigraphic profile where in the same profile on one end, several meters away, you can see that they are showing these trackway footprint trackways. But a couple meters away, they took their samples. Now, we don't probably need to get into all the details, but there's arguments about the stratigraphy because the area where they have the footprints is not where they took the OSL samples. In the place they took the OSL samples, there are no footprints. So we have made the argument that they are dating some other deposit that is not related to the track. All they really needed to do was sample above the track. I know there's some technical challenges of getting quartz, but as far as I can tell, they didn't even try. There wasn't even an effort to take those samples. So I'm a little confused, sort of even to this point, as to how that argument works, because it's a rather straightforward proposition. Just simply date the sediment that's burying the trackway. And that has not yet happened.
My guess is they couldn't find quartz, and the only samples they had enough quartz in, and would happen to be that one. Because in the stratigraphic column figure, they have it's like this anomalous layer they right in the column is where they took that from. So maybe there are some unique sediments in there that were.
It's not like there's a bunch of
rich
samples that they show that they tried.
Yeah, they don't show that. Yeah, they don't. Exactly.
I mean, that's also in science, we talk about negative evidence. So it's not like you took those samples and go, well, you couldn't find quartz. It doesn't seem like they even tried. Or if they did try, they don't record it. So I don't know.
They should definitely record it if they couldn't find quartz. And I don't remember reading if they had mentioned that they looked other places and they couldn't find quartz. So let's say, they found quartz though in at least one layer. It's not really where the footprints are, but there still can be issues with OSL because of all this gypsum. Can someone talk about why would the gypsum affect the OSL dating? Anyone want to talk about that?
The paper in which we responded to claims of Pagadi et al. With the OSL dates, Christina Neudorf, who is an OSL specialist, she did a real nice job of laying out various possible reasons why these OSL ages are not accurate and, in fact, are probably maximum limiting ages. That is to say that they have to be older than the real age of what that layer of quartz sand is. And one of the reasons that she brought forth is gypsum powders, clays, and silts can coat the quartz sand grains that you're trying to date and dilute the signal, the light signal or photons that the luminescence technique relies on to get an age. So that was one problem. Another problem that she brought forth is that of partial bleaching, and that is that if you're taking a sample of sand grains and trying to get an OSL age out of these, some of the grains may not have been fully exposed to sunlight to where they're starting at a base level when they are deposited. And then the signal then builds from that base level. If you fully bleach all of the sand grains in a sample, you may get an accurate age estimate at the end. But if some of the grains were not fully bleached and started at still containing partial signal, those are going to affect the age estimate, and it's going to make it seem older than it really is. And so that was a couple of her big concerns about the accuracy of the ages. And she has some others related to how the dose rate of the signal is calculated, the effect of variable water content of the soils, which can also affect how the signal is propagated in the soil column. It's quite a technical issue, and there are a number of possible problems that will affect those ages. So the upshot was that we thought that rather than Pagatti's asserting that that date had to be, the actual age had to be older than that date, that it was a younger limiting age, we think it's more likely that that date is it's a maximum limiting age. And we don't know how much older than the footprints themselves. So if that's the case, and that date is at the bottom of the stack of footprints, then all the footprints have to be younger than that.
Yeah, that OSL date is at the bottom of the stratigraphic column, supposedly on the figure.
Did I get that right, Loren?
Yeah, and there are 3 OSL ages, by the way, that
there's 3
publish. Yeah, and also too, they're not the same age, so each one is different. So in the end, they choose the oldest one, and they say, as Dave Rhode's mentioning, we think that as a minimum, it has to be this age or older. And we point out, well, you don't have to do it that way. That's just your interpretation. It could be younger. So the younger one is, significantly younger than the oldest. So, I mean, again, it just shows that it's the difficulty of doing this work. And so we talk about these things with a degree of respect, of course, too, because we understand this is challenge. This is not easy stuff to do. And we are sympathetic to them. And we're also, I should say, we are also pleased that they're trying to figure this stuff out. It's just that the scientific process is one in which hard questions must be asked. And you cannot just wave stuff away. Like, that's not the way science works. You just need to keep on going, and we're going to beat on these ideas. And if they can survive toward the end of the day, then maybe we decide that's the answer. But we're still in the beating process, I guess.
And I would love for Pagatti or Bennett to come on here, because I've emailed them. I have not heard anything back. Maybe they'll respond to me. And I think Desert Drifter and Dave Rachal made the point, extraordinary claims require extraordinary evidence, and they are making extraordinary claims. So we have to definitely look for, the evidence has to be extraordinarily good as well. And it seems like that's why we're here critiquing this. It's not anything, like you said, against Pagatti. And man, they've put a lot of work in, let's put it that way, and a lot of effort to do these papers. And so I appreciate it. And it's super interesting stuff, even if they are 15 or 10,000 year old footprints and megafauna tracks in that lake. That's phenomenal stuff. But let's still stay on Pagatti, because they did throw a new line of evidence for dating. It may be still on radiocarbon. So they did produce radiocarbon dates, a new method in their paper. And this was isolating terrestrial pollen using a novel technique, this flow cytometry, which essentially they took large amounts of sediment, relatively speaking, like about 1 kilogram of sediment, because it takes that much sediment to isolate just the pollen out of it, to then be able to date. So that pollen grows on the land in the watershed around the lake and is not supposedly affected by the hard water effect like Ruppia is. They were able to get 3 pollen ages over that same stratigraphic column or area where the footprints are, where they did the seed ages and the 1 OSL date, or near there. The three pollen ages do line up with roughly 20 to 3,000 years ago. Admittedly, though, and they admit it, with extremely large 1 sigma error of 2,500 years. If I believe it's 1 sigma they put in the paper. So 2 sigma, 95% confidence puts that at 5,000 years. So if you have a 20,000-year-old date with a 5,000-year-old error bar, that puts it at 15,000 years possibly, within 95% confidence. So, but guys, what is the issue then? The pollen dates shouldn't be affected by the hard water effect. Why don't you buy those dates? Who wants to talk about that?
I'll jump in here. So you're absolutely right. The pollen that they collected to get the radiocarbon dates are from these montane conifers that grow in the upper mountains surrounding the lake.
So the pollen gets blown into the lake, incorporated into the sediment. They're not dating pollen from trees, but they're dating pollen that fell into the lake, supposedly.
That came from the pollen rain that covers the whole landscape that gets deposited into the lake. It may be washed in via streams like the Lost River that comes into the same area as well. But
what's pollen made out of? Why is it so tough? Why doesn't it just break down?
It's like a natural plastic it's not plastic, but it's some organic material that is really tough and preserves extremely well the outside coat, the exine of it, something called sporopollenin, something. But it's an organic material that preserves very well in the sedimentary record. And so you can find fossil pollen dating back hundreds of millions of years, well, as old as flowering plants and conifers. But so it preserves for a long time. It can get deposited and then stay in the deposits for a long time. If somehow you move those deposits through erosion or something like that, the pollen might come along as sedimentary particles along with the sands and silts and get redeposited someplace. These pollen grains, especially from the pines, they're really robust and they can survive being redeposited and just being contaminant in a younger deposit. And so you have a situation where you may have pollen that was thousands of years older than the sedimentary deposits were when they were laid down in those sedimentary deposits. And so what we think may have been happening here is that they had, as part of their processing, deliberately gathered these large pine grains from the deposits. And there's good reasons for that, because they're really large, they're really robust, they have a large amount of carbon in them. If you can sort those out, you'll be able to get a radiocarbon date with as little as 75,000 pollen grains. But it's a real trick. It's a technological feat to be able to separate those out using a cell sorting technology and to make sure they're of adequate purification to be able to know just what you're getting for that, and then to be able to date those. And so that's really pretty neat. The problem is that when were those big montane conifers most plentiful on the landscape? Well, it was during the last glacial maximum, 23,000 years ago. That's when they had their biggest distribution in the area. And so if you were looking just to date those big conifer pollen grains, the pines, the ponderosa pine, the southwestern white pine, limber pine, you are very likely getting a biased sample of the pollen grains that are in the sediment that you're dating, because that's what you're going after. Well, it may also be biased by age, that if you're going after those, you may have a bias towards the last glacial maximum period, and that would be the date that you would get. Now, the other pollen grains that were in that same sample that they did not use for radiocarbon dating, they may be smaller pine grains from the lower elevation pinyon pines. They may be sagebrush pollen grains. They may be grass pollen grains. They may be other desert plants, for all we know, shad scales and salt bushes and things like that. And if you were to date those pollen grains, we don't know what we would come up with. They argue that it was all of the pollen grains in their samples were contemporaneous, but that's just assuming what they want to assume. And if that is true, why would you even go bother just going for the big conifer grains? No point if they're all contemporaneous. But it would be really interesting to take all of those grains that they didn't date and see what date that came out to be. It might be, well, we don't know. It could be a lot younger. That's the issue with the pollen grains, is that through the processing, you can introduce the either deliberate or biases that are either deliberate in the sense of we want to select these because we think they're going to provide a better date, or biases that you don't anticipate. I'm sure they did not want to go after those just to get a last glacial maximum date. That would be ridiculous. But so it's always a situation when we're doing this kind of archaeological and paleoenvironmental analysis to be thinking about how our methods of study and methods of measurement, methods of analysis affect the results, us introducing certain biases.
So, and also too, this comes back to the theme I said before about when you're applying radiocarbon dating to something, all you're doing is measuring the time at which either in this case with pollen, when was the pollen created? Like when did the tree actually produce and emit the pollen? That's the only thing you can say with certainty that you are dating. When it arrives at the area with the footprints is not that necessarily that same age. Now they assume, for the sake of argument, that it is the same. That just as they assume that the Ruppia itself is being created. They've even argued in other papers that it's growing at the footprint site, but that's not likely possible, depending because of the way that which Ruppia requires its habitats. But the point is that their model of dating is reliant on a whole bunch of things exactly happening just so. They have to happen in just this kind of way. So by definition, if you're going to find pollen from pine that grows at the top of the mountain, if you find it in the lake basin, then you know that it has to be redeposited. And the timing between which it was created from the tree and when it arrived at the site is not known. You can't know that with certainty. All you're doing then is just making the argument that the dating of the pollen actually dates the timing of the footprints. But as you pointed out, the error bar is so enormous.
Yeah.
I'm not even sure really what the value is in this, because it's like at 2 sigma, which for your listeners is like, what are you, 96% certain that the age?
Well, yeah, like 95.4. Yeah, something like that.
So you say at 2 sigma, which would be plus or minus 5,000. So
Yes.
that is the error bar is the scale of the Holocene, which is a geological time period where most of archaeology in the Americas occurs. So you're saying that's the level of our uncertainty. And it's like,
That's the and that's
wild.
they admit that that's pretty large. And also for people that are watching, listening, Willard Libby's error bars on his original dates when he invented radiocarbon were like plus or minus 500 years. I've dug into the history of radiocarbon dating back to the guy that invented it. And that was back with his old Geiger counter thing. But so yeah, a 2,000-year-old 1 sigma or 1 standard deviation error 2,500, is huge, especially in 2025. Absolutely enormous.
well,
And also for other people that don't know, all these ways of dating lake sediment we're talking about now, aquatic seeds, OSL dating, and pollen ages, are not optimal dating techniques for lake sediment dating, period. These are all like, I know this is an extreme site, amazing site. They had to push the techniques to the extreme ends. But the bottom line is these are very difficult ways to date sediment. And sorry, what were you about to say?
I was just going to say, one of the things that's a bit of a problem with the way that these ages are being sort of presented is that there's a lot of wording in the most recent papers where they say the fact that the radiocarbon ages on pollen and Ruppia and OSL all overlap in time is proof that they figured out the timing of it. It's that, they have convergence on this age. But that's like saying something that dates between now and 1 billion years ago, and now and 1 million years ago, and now and 100,000 years ago are all the same age, because there's some part where they all overlap. It's like, yes, but that's not meaningful, because the age ranges are so broad, they're super inaccurate in the way in which these issues of time would be important. So I think people need to just slow down and remember that we weren't there. So a lot of this kind of stuff, as I say to my students, archaeology is argument. So you're going to be hearing some argument here. It's not like we exactly know what happened. We're trying to figure it out through these techniques.
Mm-hmm.
There's also an issue of trying to sell your point of view. So remember, it's not unbiased.
Mm-hmm. And I take back everything I said about coring the Otero Basin for paleoclimate reconstruction because I don't know how you'll date it. This sounds like an incredibly hard. If you had a nice core that spanned like the late, Pleistocene, I don't think you'd find any dates in that thing that anyone would believe. So you really wouldn't be able to do much with it. And man, that stinks. But as you were talking, I, had kind of light bulb go off. And I was thinking, how about this? So we know the footprints are megafauna footprints in the lake, and the lake dries out of 5,000 years ago. And I'm assuming that date on 5,000 years ago. I really am harping on that because I've seen mid-Holocene reconstructions, but I'm assuming that date is solid 5,000 years ago. When did the megafauna, when were they extirpated from this watershed? Do you have an idea, Dave, Rachal? Like, when was the last ground soft there? Because wouldn't that tell us somewhat about the ages of those sediments? Any thoughts on any of the megafauna extirpations, the mammoths, anything in that area?
Well, it's interesting you brought that up. We know there aren't any ground sloths now. The latest continental date on ground sloths is something like 11,000 years old. It was part of the great megafaunal extinction at the end of the last ice age. So a lot of big furry animals died out after the last ice age. It's been a topic of huge discussion for a long time. How close they line up, their extinction ages, is a big question. Some of the native horses may have gone out pretty early. The ground sloths may have gone out about 11,000. I don't think we have really good dates for the Tularosa Basin itself for that. But if you were to think more broadly and say, well, okay, ground sloths in the Americas all died out by 11,000 or 10,000 or whatever. Well, that puts another limit on those ground sloth footprints that are in the Tularosa Basin. They have to be older than 10 or 11,000 years old. And so that's one way of getting a minimum limiting age on those footprints. And if the human footprints that they found are spatially associated or with ground sloth footprints, and they have some instances where that is the case, then that is using those extinction ages. That's one way to put a limit on it. Another possibility is that if they are down below the maximum extent of Lake Otero, that we think may have dated 25,000, 24,000, 20,000. That's not really clear. And that needs some dating too, but that also puts a limiting age on those footprints. And so you might be able to guess that, okay, between about 11,000 at the young end, the maximum age of Lake Otero at the older end, and also other estimates of when humans first entered the Americas, which from Loren Davis's work at Cooper's Ferry and a number of other localities may be at least 16,000 years old, something like that. So now you're beginning to get a ballpark idea of what the ages of those footprints might be. Be any younger than 10 or 11,000 because of the sloth prints that they're associated with. They have to be there after people arrived, right? Obviously. And so now you got it down to about 11,000 to 16, maybe 17, if you're pushing it, maybe 18, something like that. And that is exactly the kind of argumentation that a previous paper that was done in 2018 by David Bustos on the human footprints in this area, that's exactly the argument that he made. And really? I thought it was really strong. Dave Bustos and a real strong team.
Another Dave?
Another Dave. You can't
What
get away
is
from
going
us.
on here? What is going Dave Bustos? What?
Yeah, he's the park archaeologist out there, and
Wow.
he's one of the co-authors in all of these other papers. But I thought that was a really strong way of getting a chronological envelope around these things. And then this paper, the Bennett paper, comes out 2-3 years later and blows that one kind of out of the water. But we might want to revisit that kind of thinking a little bit, because they may have been onto something early on.
One thing I want to just clarify is that, as Dave Rhode mentioned, we have evidence, let's say, of human presence at the site in western Idaho, Cooper's Ferry. That doesn't put any weight on any other kind of interpretation anywhere. So, like, if you say, well, there is maybe evidence of human footprint creation at Lake Otero 23,000 years, it would be improper to just point at another site and say, yes, but at this other site, it's only 16,000. Because that's not really how it works. We take each claim has to be addressed case by case, because it could be that, and I think this is probably true, the archaeological record at Cooper's Ferry, the Paha, as it's known in Nez Perce language, is not exclusive. It doesn't necessarily mean that we've seen the earliest evidence of everything. It just is what it is, to quote a phrase that my colleague David Madsen loves. And that essentially it only is the record that we can date there. And there could be earlier things elsewhere in the landscape in western Idaho that could be 23,000-year-old sites. We just never found them if they exist. And so I just want to make that clear. We're not trying to say we're biased at putting an artificial boundary on it and say it can't be older than this, because I've never seen it. That's a terrible argument. I hate it when people say that instead.
But at least we could
That's
say,
true.
like, when you point to Idaho and you say there's evidence 16,000 years ago, and then we can at least say we raise the possibility that humans are in the area of North America at that time. That doesn't necessarily, that doesn't necessarily give us weight
Also, I would say if a lot of these issues we're talking about could be resolved to a level that we feel confident in the data, we understand the timing of it. And let's say the OSL dating on sediments immediately above the footprints came back, and you can check all the boxes, the technicalities of how it was all done and all these things. And it confirmed that it was truly 23,000 years. Then if I'm presented with what I think are pretty much undisputable facts, then I could change my mind. No, it's not like I'm locked into this. It's just that the things that we are talking about here are just simply issues that we still think that are not resolved. These are not resolved issues, even though that's something that the other authors are saying has been done. That's not how science works. You don't get to claim that something has been resolved because you say so. It has to work itself through the scientific process.
Agree. And I'm glad. Thank you for clarifying that. That's a great point. And kind of maybe like the final end of this discussion and maybe a chapter, let's say, is the lack of artifacts, period, in New Mexico dated to 20 to 23,000 years ago. That's a gigantic hole in the story, let's say. Not, again, the lack of evidence is not necessarily evidence of anything, but it is very strange that nothing has been found dated to 20 to 23,000 years ago. And I just want to step back a little bit, and I'm going to give this off maybe to Dave Rachal, because I know you talked about this in Desert Drifter quite a bit, or you had a good little spiel in there. And the reason why these 20 to 23,000 year olds, like the dating is such a fantastic, age is, first of all, it's during the last glacial maximum. It's when terrestrial continental glaciers reach their maximum extent in the late Pleistocene. And so the majority of the northern hemisphere, especially in North America, is covered in ice. And so the model in the past of the population of the movement of humans into North America was that the ice sheet had to melt a little bit. So this ice-free corridor opened up between the Western Rocky Mountains in Canada and like the Great Plains, and people could migrate from Alaska down through. This was eventually, this model held for a little bit, but dates were found that were older than this ice-free corridor. And so recently we've moved to this coastal model where the people from Asia that came across the Bering Land Bridge probably migrated into North and South America along the western coasts. And so this has kind of been the model. There's a few old sites in Chile and across Western North America, and I'm sure you guys know more about those, but they're limited to about 16, 14, 15,000 years ago. Am I right? As like the oldest evidence, solid evidence in North and South America, like Monteverde in Chile. There's the site in Idaho. So if there are dates of human footprints at 20 to 23,000 years ago in New Mexico, that changes everything. It came during the LGM. They're way older than the ice-free corridor, and they're older than any evidence we have on the coast for this coastal route. So that's why this is such an extraordinary claim. And, well, guys, so I covered everything I wanted to talk about, and I just wanted to recap. The inspiration for this whole conversation is the Dave Rhode et al. 2024 paper titled Unresolved Persistent Problems with the White Sands Locality 2 Geochronology. I'll have that in the description for this video. Please check it out if you're interested in this. Do you guys have any projects or papers coming out on this subject that you want to maybe shout out so anyone that's watching this can keep an eye out for? Any papers, studies, anything like that? No. Do you know if anyone else is working on the footprints and dating them still?
Heard an unsubstantiated rumor that there may be some more dates coming out.
Okay, we don't have to put any names, but there are rumors of new dates that in the future we should all be looking out for. And, maybe as a sign off, then let's all three guess what did you think the true ages of the footprints there are? What are the oldest ages of the footprints in the Otero Basin? What's your best guess? Dave, Rachal, what do you say?
I think it's terminal Pleistocene in age. I think it's going to line up with Clovis.
So what would you say
opinion.
in years before present? What would that be?
I think it'd be anywhere from 14 to 12,000 time frame, somewhere
14 to 12. To Dave, Rachal. Dave Rhode?
I'd go a little broader, 11 to 16.
11 to 16. This is for the record, folks. So down the road, we're going to be able to compare what you guys say. And Loren?
Well, I would agree.
Loren, sorry.
That's okay. I would agree with David Rhode. And we said as much in that paper that you are going to put online in 2024. We give our own guess, correcting the Ruppia ages as we think they could be correct.
So you're on the camp of 12 to 14,000.
Maybe
years.
like 11 to 16, like Dave Rhode said. I think
Dave Rhode said
that's not
okay.
That's not so unreasonable. So, but hey, could be older. I'm willing to have my mind changed, but we need to see better.
Well be older.
We need to see better data. So
we could find out these are only dated to 9,000 years ago, and you guys are all too old too. Maybe
that would be.
But then the
wild.
Megafauna would be very young there, because I was looking up the youngest dated Megafauna, at least in the Great Lakes area, is dated to 11,500 years ago, and so that's the youngest mammoth mastodon fossil I could find. I don't know anything about New Mexico though.
So one thing I should say at the very end is that yes, this is not resolved. There's still a lot of questions outstanding, but I think we should also remember too that it's pretty amazing that you can get preservation of things like this, megafauna footprints, human footprints in some situations. But as Dave Rachal has pointed out, there's still questions about footprints too. Are they all what we think they are? But I think what it highlights is that this is a really special place on planet Earth, and it has a really cool record. What the timing of it is something else, but we don't have to worry always about the timing to enjoy these two.
Well, even if it comes back like terminal Pleistocene, it's still the oldest site in New Mexico. It's still a tremendous archaeological find, and we don't need to lose sight of that. It comes back 21 to 23,000 and older. That's fantastic too. But regardless, it should have a building over it. It should be protected, however it shakes out. It definitely is terminal. It's definitely Pleistocene. It's just the argument if it's LGM or terminal. I think we're going to figure that out real soon. And In either way it shakes out, it's still amazing.
It's a real exciting piece of work and a real good example of the scientific method and how the scientific process works, of contention back and forth towards eventually some kind of resolution. We're not there yet, but I think in the not too distant future, next couple of decades, we might get there.
It's a great way to end it. And I also, the way they were able to map the footprints, I think remote sensing wise or ground radar gravity anomalies, maybe you guys know more. In the Pagodi paper, they were able to actually sense where these footprints are. I think that's an interesting way to maybe look at demographics and the movements of animals and people in that area.
I haven't heard that.
Yeah, we're able in the Pagodi paper to identify these footprints somehow by doing a survey, I believe, over the
using ground
trench.
penetrating radar.
Okay, ground penetrating radar. I just forgot which one. But that alone was like, well, that's pretty phenomenal. You could pick these footprints up with ground penetrating radar, right?
You can get shapes.
You can get shapes, yeah, I guess. And then, but if you made a map of like a pretty extensive part of that basin, couldn't you maybe like see, movements and tracks and, I don't know, categorize them as
think the technique doesn't resolve it down to being 100% certain about who's making what tracks all the time, I think. But because you see images where they have individual toe prints and things like this. And I know we're almost out of time, but that's another issue too that we really haven't gotten into. For the sake of argument, we've taken, the team footprints, claims at face value that everything they're showing us is exactly human footprints. But remember, archaeology is a bit of a faith-based exercise because you weren't there. You didn't see those things get excavated. You're not 100% certain that they are. And so we take their word for it. And there's no reason for us to doubt it. But there are people that do ask questions about what is the way in which these things are actually get excavated. Does it always need to show up in a way with the really resolved, toe prints and so on. So
I think what concerns me more than anything is that, we don't have standardized protocols, and that we don't. And that's going to be problematic because they're going to start finding these prints all over the place. I'm sure it's a matter of time before they start finding them at Guadalupe Mountain National Park and the Lake King Playa. And, I think we need to sit down and come up with excavation protocols, standardized ways to identify, because it's not that easy. When you're out there, there's so many processes and so much erosion. The landscape's hammered. It's easy to get tricked. It's easy. It's not that clean. I think putting together some protocols and all that will go a long way, because this is where North American archaeology is going to go probably with these studies. More and more they find these footprints, and more they beat that drum. We're going to find them all over the place. Some of them could be legitimate. Some of them might not be legitimate. And if it gets too big, it's probably going to fall apart if we don't have any type of archaeology that dates to it. All we have is footprints.
Yeah.
We don't have any lithic tools. We don't have any hearths. It'll collapse in on itself. And I think that's really important and where we need to go.
I think that's a great point, is
get some
the
methods.
Lack of physical evidence for humans in New Mexico. A hearth, pre-Clovis points, something dated to anywhere near 20,000 years ago. There just isn't, right? So
yeah, but that stuff is really hard to find,
True.
And just even finding the layer of sediment that dates to that age above the level of the lakes could be tough, for the reasons that David Shelf mentioned, a lot of erosion and things like this. So I don't know. And also it's a bit of a self-fulfilling prophecy. If you don't believe that something could be 23,000 years old, you don't tend to look for it. Or if you're excavating the site, you get to 12,000 years, sometimes people go, well, that's it. There's nothing that has to be below this.
True.
I'm just saying there's a lot of reasons why things could go the way they are. It looks like Dave has a question.
Yeah, and Dave, go ahead.
Well, one thing though, Loren, is that, this is not some random basin in Nevada or up in Basin Range where you guys work in Oregon. 1 million acres have been systematically surveyed.
Well, that's our official expression.
50,000 square meters of excavation has occurred. Thousands of hearth features. This place has been looked at for 50 years. Yeah, we could have missed it, sure, but this place has done its due diligence. The archaeologists here have done their due diligence just because it's on military. Most of the basins and on Fort Bliss and White Sands Missile Range. It just seems like we would have found something.
But to that point,
what do I know?
If you're just working off of the evidence you have, you would then could make the argument that Clovis is not real because you haven't found it. So, I mean, taphonomy is that is the issue of how things become part of the archaeological record. It's tricky and complicated. But I take your point. You think that it can show up right now.
Well, and another point or example of that is in the Bonneville Basin in northwestern Utah. We've been doing studies in a place called the Old Riverbed Delta that drained into Lake Bonneville and done work there since, 2000 or so. A lot of survey. We found some footprints. They're on the playa. After all of the work that we did over the past 25 years, the first footprints were found in like 2023 because people weren't looking for them.
Yeah.
Didn't expect to find them. And it's pretty much as a result of the footprints in the Otero Basin that people thought, well, maybe we ought to look for someone. By the way, what's that over there? And, look at that. It's a footprint. So it is kind of, you find what you look for.
So it's going to be, this is going to be a hot subject.
It'll be a hot topic.
Yeah.
And Dave Rachal's advocacy for some standardized protocols for examining these things and trying to get the best record out of them is a good one.
Great. And on that note, I think, unless somebody has a final thought, let's wrap this up. Guys, this was amazing. I think you answered every question I had. My feeling is, I hate to say it, I love being the underdog. I love like meteorite impacts. I love all the crazy stuff. And I'm on the camp that I do think these dates are younger too. I think they're going to be dated to something like you guys said. I'm going to put myself on record with Dave Rachal as 12 to 14,000 years ago, years before present. And that's just my shooting from the hip kind of guess. But yeah, man, I wanted them to be old. I've been following this study for so long. And last night after watching the Desert Drifter, I shut it off and I was like, dang it. But this is what I love about science. I love these kind of intersections between human history, geology and everything, and climate, limnology. That's all up my alley. And that's what this whole channel is about, by the way, is bringing the actual people writing the papers on YouTube to talk about what they've done rather than synthesis from popular authors and things like that on big podcasts that seem to be, as Desert Drifter mentioned, the 20 to 23,000 year old dates have made it on the largest podcast in the world. And people are repeating them as though they're fact. And they are saying what they're reading, and it's showing, first of all, number one, in the popular podcasts in the world, Joe Rogan, people are interested in these. And secondly, they're reading at least the headlines from these papers, but they're not digging into the details. So that's why we need that's why I feel like science has this huge communication issue. We need people to get on social media to make content so that they can people can see what they have to think and they can be part of the conversation online. With that, if you have any cool papers coming out and you want to come back on, please email me. I'd love to have you on. I love this kind of stuff. But I think, Dave, any final thoughts?
If you need any graphics,
no
I don't know if we're still live. If you need any graphics or anything like that for content to help you tell the story, just let me know. I can hook you up. I've spent a lot of time putting all that stuff together. I enjoy making science graphics.
Great. I'll definitely do that. And I'll be incorporating as much as I can into the final edited version so everyone can see pictures as we're talking and graphs. All right, guys, until we meet again, maybe we'll see each other at AGU or something like that one day.
Sounds great. Thanks for setting this up, David.
Yeah, thank you.
Mm-hmm. And we could all be
Thank you.
proven wrong. Who knows? We'll see the next round of dates.
Sure.
Yep. True. Bye.
All right. Bye-bye.
Bye.